Welcome back, guys, to another episode of Watch Me Wrench with your host, Mr. Wrench. So in my last video, I did the wiggle test. We checked the tolerance of the valve stem to the valve guide, and my heads were in spec, and I explained why LS engines will fail and what happens. And then I told you guys one way to extend the life of your bronze valve guides is to use roller rockers. So today we are measuring for push rod length, and I've already done it. I've done the measurement and I know what the number is, but I'll just show you guys really quick how I do it and what the number is. And but first I'd like to do a little bit of a comparison, talk more about these Texas Speed roller rockers and why I went with them. So you can see a difference in the size. These are heavier. I did weigh them and I gave you those specs in my last video. But you can see they are thicker and they are clearly heavier. These weigh more. You know, it's important to weigh the amount of weight on the rocker tip. So I don't have those numbers right in front of me, but the weight, the overall weight of the new ones is not much more than here than the stock ones, but the newer ones, the roller rocker ones, do have a significant amount of more weight on the tip. And that's probably because of the bearing up here, and it has a thicker casting here. You got more weight over here too. But anyhow, let's just talk about these Texas Speed roller rockers. I did a lot of research, as I always do when I buy a part for my car. I always try to buy the best. I try never to skimp out. I did a lot of research. I really wanted an aluminum body rocker arm that was stock ratio. The stock ones are 1.7 ratio. However, after doing all my research, and I had my heart set on the Yellow Terror rocker arms, but most of the aluminum body ones wind up breaking. They break over here, and they break over here. And there's a lot of posts out there on like the Corvette forums where guys ran the aluminum body ones, and sooner or later the aluminum body ones will fail. So then I accepted, all right, I'll have to go back to steel. But if you try to find a steel bodied rocker arm with a roller tip, you really don't have many choices, and you can't find one that is steel with the roller tip in a 1.7 ratio. So these here are 1.72 ratio. Now what does that do? Well, that actually, in a way, increases the lift on the cam. So believe it or not, it's like I'm essentially putting a larger cam in the motor. Not by much, but by a little amount. So when I first started this winter build, I said, let's take a look. Let's listen to the sound of the exhaust note, because there's a possibility it might not sound the same after I'm done with this winter build. And that was why, because I knew that I was running into an issue with the rocker arms, and I knew I was going to have to get a higher ratio rocker arm if I wanted steel body with a roller tip. So if you guys actually if you guys are on a budget, and perhaps if you're scared to do the cam swap, if you want to change the sound of your car and get increased performance at the same time, you could literally just put a larger ratio rocker arm in there. And believe it or not, I actually did that years ago on a Camaro I had. I was broke. I had a hot rod, I had a Camaro with the 350, and that's all I could afford to do, and it worked. I found the sheet with the difference in weight if you guys want to check it out. So overall, the factory ones were about 5.7 or 5.8. The Texas Speed roller rockers were just a little heavier, 6 ounces, or 161 grams to 170 grams. And the weight on the tip was significantly different. So the intake and the exhaust factory rocker arms had about 3 ounces or 8.5 grams worth of weight on the tip. And the Texas Speed ones had 7 ounces or 19.8 grams. So about double the weight. All right, so what are we gonna do now? All right, so now I'll show you how I measure for push rod length. And honestly, nobody does my method. I think my method is the best method. I'm not trying to toot my own horn, but I'm not going to go into crazy details. I'll just do one, and I'll show you guys how I do it. All right, guys, so when I did the wiggle test, I worked on the number 1 cylinder, and I had the motor at top dead center. Now, when the motor's at top dead center, you'll have a number of valves that'll be fully closed. So right now I'm on the passenger side. So on the passenger side, the intake on the number 8 cylinder was fully closed, and the intake and exhaust on the number 6 cylinder were fully closed, and so was the exhaust valve on the number 2 cylinder. So 1, 2, 3, 4 were fully closed. And why do I say fully closed, and what's the big deal? Why does it have to be fully closed? Well, you can't do this test properly. You can't measure if you have pressure being applied on the valve spring. You want the lifter to be on the base circle of the cam. What is the base circle of the cam? Basically the bottom side of the cam that has the least amount of lift. If the cam is on the base circle, so if the lifter is on the base circle of the cam, the push rod is not pushing up onto the rocker, forcing the tip of the rocker down on the valve, which would apply pressure. So on this one you can see it's compressed down. So for this test I'll just work on the number 6 cylinder. I'll do the intake and the exhaust. And let me see if I could somehow get a stand. I'll just hold it. I'm not going to make a big deal about this time. All right, so let me just get some tools and I'll be back. Okay, so how does Mr. Wrench measure for his push rod length? Well, I've showed it before, so I'm not going to go into too much detail again. So we're going to be working on the number 6 cylinder, the intake valve. So then the first thing I do is I take the bolt and I try to find where the bolt first grabs on the threads. No. So right there. And then I take a white compound and I mark the bolt at the 12 o'clock position. Now the bolt will always grab in the same spot. So it's not going to grab here. See, it grabs right there. So the bolt will always grab in the same spot. Now I count how many turns until the bolt makes contact with the trunnion. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15 3/4 turns. Just give it a little snug. Okay. So basically 15 3/4 turns. Okay, so keep that measurement in mind. And then take the bolt and the rocker arm off. Okay, now get your push rod length checker. In my case, I'm using Comp Cams 7702, and with this thing fully closed, it measures out at 6.8 inches. And for every rotation on the end here, you add 50 thousandths to 6.8. So let me just, it's hard to do with one hand. So there's 50 thousandths. There's another 50 thousandths. So I'm going to start off with 11 turns on here. Okay, so I have this on 11 turns. So right there, you see the hash marks are lined up. Now here's a little trick that I just figured out this time. This thing, when you pick it up and you're trying to put it in, you know, it will turn and the hash marks don't line up. See, they're kind of off. So as you pick it up and you're dropping it in, it'll turn a little bit. So to avoid that, cut yourself a little strip of blue painter's tape and then put it on across the two pieces, and it'll hold them in place. Okay, so I put it on the back side, a little strip of tape, got the hash marks all lined up, and now I will drop it in to the hole. Push down, make sure that the push rod is seated in the plunger of the lifter. Get the rocker arm I'm working on with the bolt. Make sure that the push rod falls into the cup. And then get the bolt in place. Okay, right there, grabbed. And now let's count the turns. So we had 15 and a quarter before. 15 and 3/4, sorry. 15 and 3/4 turns. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and we'll get 3/4. Okay, just give it a little tug. Good. Okay, so now I know the rocker is fully seated in the pedestal because the mark is in the same spot, 15 and 3/4. 15 and 3/4 turns, we're in the same spot. Right now we're going to check the lash. Right now what you're looking for is 0 lash. Lash is this right here. See, there's some up and down movement, and you can hear it. Okay, you don't want that. You want no lash. You want no movement here. But I know 11 turns on the push rod is not the right length, so I just wanted to show you guys. It's close to what I need, but it's just too short. All right, so now let me do it again. And the freaking phone's gonna die. Okay, grab the push rod length checker, and now I'm going to go, so we're at 11 turns, I'm going to go to 11 and a quarter turns. All right, I'll be back. Okay, so I've got the push rod length checker at 11 and a quarter turns. You can see the hash marks there. So we're at 11 and a quarter turns, so I'm going to carefully insert it. Make sure it's down in the plunger of the lifter. It is. Grab my rocker arm and bolt. Try to get it in place. Make sure the push rod is in the cup of the rocker arm. There you go. Get my dot at the 12 o'clock position to where it first grabbed, to where the bolt first grabs. It is grabbing there, okay. Looking for 15 and 3/4 turns. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 3/4. Right there. Just going to give it a little snug. Okay. Okay. So, I know the rocker arm is fully seated in the pedestal. We got 15 3/4 turns on the bolt. Now we're going to check for lash. Again, we want 0 lash. So here we go. Look at that. No movement. So when I had 11 turns on the push rod, it was too short. If I put 11 1/4 turns, it's just perfect. There is no play. There's no lash, and that's what you want. So I already know if I go to 11 1/8 turns, there still is the slightest amount of play, because I've checked several of these already. So I know 11 1/8 turns is no good. The magic number I need is 11 1/4 turns. Alright guys, so since I'm using my phone, I don't have a calculator to show you the math, so I just wrote it out for you. So here we have 11 1/4 turns. So you take 11 1/4 turns and you times it by 50 thousandths, which gives you 0.5625. So then you take 0.5625 and you add that to the base length of the pushrod length checker. So that's 6.8. So if you add those two together, you get a base pushrod length of 7.3625. Now, that is not the final pushrod length that you need, because you have to add the recommended amount of preload. So for my Morel lifters with an aluminum block and aluminum heads, Morel recommends 50 thousandths preload. So if you add 50 thousandths to 7.3625, you get a final pushrod length of 7.4125. All right, so Texas Pete says you're going to need a pushrod that is about 0.175 inches shorter than the existing ones you have. But according to my math, I need one that is 0.1875 inches shorter. So I was running 7.6s, and now I'm going to need 7.4125. So my new push rods are going to be 0.1875 inches shorter. I don't know if that's a very common size, 7.4125. So there are manufacturers out there that'll custom make any length push rods. I do want to go with a beefier push rod. I believe Manton makes some really good push rods, so I might try out Manton. I have comp cams. These work fine. But you have to be careful with a push rod. Most of your valve train deflection actually happens at the push rod. And why? That's because you have such a large gap between the rocker arm cup here and the lifter all the way down there. So you have this long span, you have this skinny metal hollow pipe, and that's where you get a lot of deflection, is in your push rod. So don't skimp out on push rods. Get heavy duty beefy push rods if you can, especially when you're approaching horsepower numbers like I am. I mean, this motor is currently at about 900 crank horsepower, probably a little over 900. Maybe after this build with some upgrades, we're going to make some more changes up here. So maybe after we do all the changes, you know, the motor will be at about 1,000 crank horsepower. And that's probably about it. You know, that's probably about all this stock bottom end can handle. You know, they say it can handle up to 1,000. So we're going to find out, that's for sure. Hopefully it doesn't blow up. All right, so that's it. Anything else? I don't really want to get into like why I count the threads. If you guys want to know why I count the threads, please watch one of my earlier videos on how to measure for proper push rod length. All right, guys, I just want to touch on one thing. Without a doubt, the question that I receive the most out of all my videos, which is like 100 videos that I've posted, and that question is, won't tightening down the bolt increase the preload or affect the preload? And the answer to that is no, not at all. It's very simple. Let me take one of these rocker arms off and I'll show you. Okay, so you see this? Here we have a solid pedestal mount for the rocker arm that doesn't move or flex. And on the other side here, what do we have? We have a solid trunnion made of steel that doesn't flex or have any give. So once these two surfaces are together, once that trunnion is sitting in that pedestal, there's no play. So it doesn't matter if you torque this down to 5 foot-pounds, 20 foot-pounds, or 25 foot-pounds. It's not going to have any impact on the preload because the rocker arm is not going to compress down more, forcing the rocker arm cup to push down on the push rod, which will push down on the lifter. There is no give. So tightening these bolts or torquing these bolts has no effect on preload. Zero. Zero, zero, zero effect. That's why when I do my test, I just do like a nice hand tight. I do a nice snug. I don't go and torque it to the final spec, which I think is like, what, 25 or 26 foot-pounds? Because even if I do it to that level, it has no effect. And how do I know this? Because I've tested it out myself. So I'm comfortable saying that. So that is, without a doubt, the question that I receive the most. So tightening the bolt has no effect. All right, guys, I'll be back.